Welcome to this video. In this video we are going to discuss about problems on dynamic equation of gradually varied flow. In the previous classes we have gone through the derivation of this dynamic equation dy by dx, which is equals to s naught minus sf divided by 1 minus Froude number square. So let us use that equation in order to solve these few problems here. So this dynamic equation helps us to understand how the depth of the flow changes along the length of the channel, along the direction of the flow. Okay, and it also helps us to find out what is the length over which this change in depth of flow is actually taking place. And we have discussed about wing walls and the importance of wing walls and how this equation helps us to decide the height of the wing wall. Okay, so let us go to the first problem here. So please read out the question here. These are very simple problems, and you will know that when we solve these problems. So this is a rectangular channel of 12 meter wide and 3.6 meter deep water is flowing with a velocity of 1.2 meter per second. So this is the velocity, this is the depth y, and this is the width of the channel b. Now the bed slope of the channel is 1 in 4000. This is nothing but bed s naught. Okay, that is how we write bed slope. Of course different textbooks use different denotions. Okay, for example, in some textbooks it can be written as SB. B is nothing but bed, slope of bed. Here we have used S naught as the notation for bed slope from unit 1. So let us follow that, or you can follow whatever it is comfortable to you. Next, if the flow of water through the channel is regulated, అంటే కంట్రోల్డ్ చేస్తే ఏ విధంగా అంటే the total energy is having a slope of 0.0004. So you are controlling the flow in the channel such that the total energy line is having a slope of this. So SF, right? SF is the notation that is used to represent the slope of the energy line. So S naught, SF, both are given. Okay, of course it is given in fraction, the bed slope, which is S naught. I'm just writing out in the decimal format for easy substitution, and the slope of the energy line, which is SF. See here, SE is used to denote it, and SB, so different denotions can be used. Okay, don't worry about that. And velocity of the flow given, depth of the channel, and width of the channel. Now he is asking you to find out one single thing. What is that? Rate of change in depth. See, this is the dynamic equation dy by dx, which is equals to s naught minus sf by 1 minus frs square. This frs square is nothing but v square by gd. So this is nothing but, this dy by dx is nothing but the slope of surface profile, slope of surface profile, or you can say that is nothing but rate of change in depth. రేట్ అంటే ఒక దాంతో కంపేర్ చేస్తే మనం రేట్ అంటాము. ఓకే, ఇప్పుడు ఎంత డిస్టెన్స్ మనం కవర్ చేస్తున్నాము అన్న దాన్ని విత్ రెస్పెక్ట్ టు టైం చెప్తే మనం దాన్నే ఏమంటాము, డిస్టెన్స్ని విత్ టైంతో కంపేర్ చేస్తే వెలాసిటీ, డిస్టెన్స్ బై టైం. వీఆర్ టాకింగ్ అబౌట్ డిస్టెన్స్ కవర్డ్ విత్ రెస్పెక్ట్ టు టైం, velocity with respect to time, discharge. So when you compare, when you say something with respect to something, then what we call as rate. ఇక్కడ మనం చేంజ్ ఆఫ్ డెప్త్ అంటున్నాం. రేట్ ఆఫ్ చేంజ్ ఇన్ డెప్త్ ఎందుకు అంటున్నాము అంటే చేంజ్ ఇన్ డెప్త్ విత్ రెస్పెక్ట్ టు డిస్టెన్స్. ఓకే, సో విత్ డిస్టెన్స్తో మనం డెప్త్ని మనం చెప్తున్నాం మాట్లాడతాం. సో we call that as rate of change in depth. So dy by dx. So you just need to find out what is dy by dx. So this is the formula, right? S naught minus SF divided by 1 minus V square by GD. S naught and SF are given in the question, so substitute them. And V 1.2 meter per second, put that there. G 9.81 meter per second square. And capital D, hydraulic, of course you know that, right? Capital D is nothing but hydraulic depth, depth depth, okay, which is equals to A by T. You know T is nothing but top width. Okay, so for rectangular channel what happens to A? Area equals to B into Y. What is the T top width? B. So now D is nothing but A by T, which is equals to B into Y by Y. Y cancel, B. Sorry, the T is B, right? B cancelled and Y. So D is equals to Y. So hydraulic depth is equals to depth of the flow in this rectangular channel case. So whenever it is a rectangular channel, hydraulic depth D is going to be equal to the depth of flow. Okay, hydraulic depth of flow is equals to actual depth of flow. So what is the depth of flow? 3.6 meter. So put that value here. Okay, so now on substituting S naught, SF and other parameters here, what do you get? This. So dy by dx equals to 0.002189. So what is this value? This value is the slope of the surface profile, or it is the rate at which the depth is going to change with respect to length of channel, or it is simply rate of change in depth. Now here you can write this in fraction also. So if you wanted to write in fraction, you simply need to just divide the 1 by answer. See here, if you write this 1 divided by 0.0002189, you will get x, I mean a fractional value. And if you write that value as, and now you can write this as 1 by x. అంటే ఏదైతే వాల్యూ ఇక్కడ ఈ ఎక్స్ప్రెషన్లో వచ్చింది ఇక్కడ అది x అనుకుంటే, అది డినామినేటర్లో పెట్టి న్యూమినేటర్లో 1 తీసుకుంటే ఈ పైన వచ్చిన 0.0022189 ఫ్రాక్షన్లో రాసినట్టు అవుతుంది అనమాట. ఓకే, జస్ట్ ఇన్ కేస్ ఇఫ్ యూ వాంటెడ్ టు ప్రజెంట్ ఇట్ దట్ వే, యూ కెన్ డూ ఇట్. ఓకే, సో నౌ లెట్ us go into the next problem.